afternoon and welcome to the City Club. I'm Owen Heggs, Vice President of the City Club. Our speaker today is Dr. John F. McCarthy, Jr., Director of the National Aeronautics and Space Administration's Lewis Research Center here in Cleveland. Dr. McCarthy is a native of Boston and obtained his bachelor and master's degrees from the Massachusetts Institute of Technology. Thereafter, he earned a PhD in aeronautics and physics from the California Institute of Technology and later completed the executive program at UCLA's Graduate School of Management. After holding posts at MIT and the Strategic Air Command, Dr. McCarthy spent several years in important positions with Rockwell International Corporation. He became a vice president of the company's space division and was involved with the design and testing of the Apollo and Saturn V spacecraft. In 1971, Dr. McCarthy returned to MIT as professor of aeronautics and astronautics, and in 1974, he became the director of MIT's Center for Space Research. He assumed his present position with NASA in 1978. Dr. McCarthy has received numerous awards for his work, has authored many papers and textbooks, and is a member of many technical and scientific institutions. His topic today is local and national impact of aerospace research and technology. Will you welcome, please, Dr. John F. McCarthy, Jr.
Thank you, Owen. Ladies and gentlemen, it's a real privilege to be here and probably a very opportune time. Let me go over the menu for this afternoon. As director of NASA Lewis, I'll begin my discussion by telling you a little bit about our laboratory. And then from that vantage point, I'll show you how NASA fits into the national scene and what our impact has been at the national level. In particular, I'll discuss three areas of activity: aeronautics, space, and terrestrial energy. Then I'll give you examples of the local and national impact in each of these areas. And finally, we'll conclude with some issues as I see them in today's environment. First, let me point out that NASA stands for the National Aeronautics and Space Administration. We are an independent agency with an annual budget of about $6 billion out of approximately $700 billion for the U.S. government as a whole. So we're 0.8% of the U.S. government expenditures. In aeronautics, we do research and technology, working with industry as a team to provide a research and technology base. And let me emphasize that NASA does not do product development in the aeronautics business. Industry develops the final products. On the other hand, for space, NASA is charged with the total spectrum: research, technology, development, as well as operations. Consequently, the space budget is considerably larger than the aeronautics budget, roughly 15-to-1. The Lewis Research Center was created as an aircraft engine research laboratory in 1941, 40 years ago. In the 1940s and 1950s, the laboratory made many contributions to aeronautics. Many of the features of today's gas turbine engines were developed at Lewis. The first hydrogen-fueled rocket ever burned in the free world was pioneered at NASA Lewis. And of course, we provided technical support to the U.S. Army Air Force during World War II. In 1948, after World War II, the laboratory was renamed the NACA Lewis Flight Propulsion Laboratory in honor of Dr. George W. Lewis, longtime NACA Director of Aeronautics Research. And in 1958, after Sputnik, the beginning of the space era, again renamed the NASA Lewis Research Center. At that time, our role was expanded to include not only aeronautical propulsion, but chemical rocket, electric propulsion, and space power technology to support the space effort. Because of our expertise in various disciplines associated with aeronautical and space propulsion, NASA was asked by Congress to assist the Department of Energy in certain areas. We now do research and technology in automotive propulsion, power conversion, wind turbines, solar cells, and so forth, and I'll elaborate on these areas later. So during the last 40 years, the NASA Lewis Research Center has evolved from a single research and technology laboratory in aeronautical propulsion to a multifaceted, highly technical center involving many disciplines. About half of our staff, some 2,700 civil servants, are engineers and scientists, and about 1,000 are skilled craftsmen and technicians supporting the engineers and scientists. Our budget at Lewis is about $500 million per year. 75% is research and development. And of our research and development monies, over 2/3 are awarded as research and development contracts to industry and universities. We pride ourselves on working with industry and academia as a team to establish the research and technology base in highly complex technical areas which address current national needs. As far as the local impact is concerned, we contribute about $125 million per year to the local economy. Our employment impact in the local area represents about 7,000 jobs. The NASA Lewis Research Center is the key government research and technology base in Northeast Ohio. Now let's look at our research activity at Cleveland's NASA Lewis Research Center and how these activities affect the local and national scene. Aeronautics, for example, our first area. Our research objectives in aeronautics involve the public, industry, and national defense. For the public, we endeavor to provide the technology for safe, economical, and environmentally acceptable air transportation. For industry, we help to develop the technology base needed to retain our nation's competitive position in the international marketplace. And for the military, we do the research necessary to maintain superior technology for U.S. military aircraft. As an example of the fruits of NASA's research and technology programs in aeronautical propulsion, let's look at the improvements in fuel efficiency over the years. The first commercial turbojet-powered airplane was introduced in the mid-1950s. Since that time, a 40% reduction in fuel consumption has been achieved through research and technology. And then, with the national and world emphasis on energy-efficient propulsion, we precipitated an additional 5% fuel savings by our engine component improvement program, which was started in the late 1970s. And current research for more efficient engines could further reduce fuel consumption by about 18%. And the concept of an advanced turboprop engine or gas turbine-powered propeller promises an additional 33% fuel savings. Now, these accomplishments are remarkable when one considers that along with the development of the technology to reduce aircraft fuel consumption, there has been an equally significant reduction in engine emissions and noise. For example, the perceived noise level has been reduced from about 125 decibels, 115 dB rather, in the mid-1950s to less than 95 dB in new aircraft engines currently being certified by the FAA. To give you some feel in the reduction in noise, 115 dB is equivalent to standing about 20 feet from a passing freight train. And 95 dB is about equivalent to road noise from your living room. The technology for these improvements has been gradually developed over the years, and most people don't realize that they are the result of extensive research at NASA's Lewis Research Center, working with industry and academia. Other research and technology projects for the future that I can only mention in passing include alternate fuels, where we are investigating the combustion of fuels derived from petroleum, shale, and oil and coal. We are looking at means of conserving strategic engine materials like chromium, tantalum, cobalt, and columbium, where the United States depends on imports for over 90% of its supply. We have an extensive effort in materials and structures research for engine durability. These are just a few examples of our activities affecting the health of the aeronautical industry in this country. A second area of activity at Lewis involves space research and technology. NASA Lewis developed and manages the Atlas Centaur launch vehicle. We are currently working on modifying the Centaur so it can be used as a high-energy upper stage rocket to go from near-Earth orbit to geosynchronous orbit with space shuttle payloads. We are involved in research and technology for advanced chemical and electric propulsion. Our activities in chemical propulsion include very low-thrust rockets that will provide a mechanism for maneuvering large space structures, such as huge antennas for air traffic control, communications, and military applications. Also, we have done extensive research and development in the technology of ion thrusters, or so-called electric rockets for space travel. And finally, our space work includes research and technology for space communications. NASA Lewis was responsible for opening up the 12-14 gigahertz frequency spectrum for commercial satellites. This frequency spectrum, which is currently being used for commercial satellites today, will be saturated in the late 1980s. Both the Europeans and the Japanese are doing extensive research work at higher frequencies with the objective of capturing the space communications market. Our research at NASA Lewis concentrates on a high-frequency band, 30-20 gigahertz, and we're working with industry in studying the potential markets for this system. We've already defined the key technology developments to exploit this frequency and hope to launch a satellite in the near future. In effect, the communication satellite would be a big telephone switchbird or a TV station in the sky, so that antennas so small they could fit in your briefcase will be feasible. This technology looks very promising, and we are working with industry for the necessary development. Our own TRW, for example, is one of the leading companies involved in this activity. Now for the third area of activity, terrestrial energy. Because of NASA Lewis's expertise in areas such as materials, bearings, lubrication, seals, combustion, aerodynamics, turbomachinery, and other disciplines, the Department of Energy has asked us to work with them in certain technologies. I mentioned that remarkable achievements have been accomplished in reducing fuel consumption for aircraft engines. If similar achievements could be accomplished in automotive propulsion, we would get tremendous reductions in the amount of petroleum we're burning. If you look at the percentage of petroleum usage in this country, almost half is used by surface transportation, whereas only about 6% is used for aviation. Therefore, we have a leverage factor, 50% over 60%, more than 5 times the potential in fuel conservation, if we could accomplish similar technological achievements for automotive engines as have been made for aircraft engines. Now, to this end, NASA Lewis, in conjunction with the Department of Energy, has embarked on 2 automotive engine programs working with industry. We are working with General Motors, who have Pontiac and Detroit Diesel Allison teamed, and Air Research and Ford as a team. Our goal in the automotive gas turbine development is a 40% reduction in fuel consumption with virtually no pollution. The technical feasibility has already been established, so the emphasis is now on the ilities: producibility, reliability, maintainability, durability, affordability, and so on, with most of the emphasis on economic viability. Now, in this area, one of the challenging technologies is the potential use of ceramic materials in the turbine engine. Our program has stimulated innovative uses of ceramic materials, which in turn has stimulated the U.S. ceramics industry. However, I should point out that the federal budget squeeze may terminate our entire automotive propulsion research effort. In the meantime, the Japanese have embarked on a broad ceramics research and technology program using extensive amounts of government subsidy. The Japanese government has committed about $60 million over a 10-year period to ceramics research alone. Another program in the automotive engine field is the Stirling engine research program. This technology resides mainly in Europe. We have a research program with Mechanical Technologies Incorporated, who is working with American Motors General and United Stirling of Sweden as subcontractor. The goals of this program are also to improve fuel economy and reduce emissions. Again, the results to date have been very promising indeed. In fact, we installed a Stirling engine in an American Motors Spirit automobile to demonstrate feasibility. We burned gasoline, diesel fuel, alcohol, and even Bacardi rum with good results. Now, we think that 9 to 10 years from now, we could get exceptionally good fuel economy for a standard-sized car using a gas turbine or Stirling engine. I should point out that an increase of only 1 mile per gallon in fuel economy for all of the 120 million cars we have on the road would save over 300,000 barrels of oil a day. Again, we have to worry about foreign competition. Foreign cars dominate the list of fuel economy leaders for the current 1982 model year. Only one American entry broke into the top 10, only one. As a shocker, in 1983, about 50%, one half of all the cars sold in the United States will have foreign-made engines due to commitments already in place. The cost of this to the United States economy will be about $5 billion a year in negative balance of trade and over 400,000 jobs. The United States is rapidly becoming a distributor rather than a manufacturer. Another area, wind turbine technology. This is a very promising project that NASA Lewis Research Center has embarked on with the Department of Energy. We are the leader in horizontal axis large wind turbines. Recently, we completed a wind farm. 3 wind turbines, each rated at 2.5 million watts of electricity. That's enough electricity for 3,000 homes. This wind farm is connected to the Bonneville electric power grid at Goodnoe Hills, Washington. Our goal in wind turbines is to produce electricity at a cost competitive with fossil fuels. We think that large horizontal axis wind machines can probably produce electricity for less than 4 cents per kilowatt hour if mass produced. 4 cents per kilowatt hour. Wind turbines will not cure our energy problem, but they can make a contribution as a clean, renewable energy source. Utilities such as Hawaiian Electric, Pacific Gas and Electric, and Southern California Edison have already ordered wind turbines. Other energy projects, which I don't have time to detail, include standalone solar cell systems for entire communities, an electric energy storage system using liquids instead of batteries called redox, research on high-temperature turbines for stationary electric power generation for very high efficiency, and a very, very promising project which would make possible the use of high-sulfur Ohio coal to efficiently generate both electricity and steam. Now that I've described some of the aspects of our research and technology at Lewis, let me briefly outline some of the tough issues that I think we face as a nation. Let's start with our aeronautics industry and discuss some aspects of its impact on the economic health of our nation. The aerospace industry in this country had over $50 billion in sales in 1980, employed over 1 million people, and has become the largest positive contributor to the U.S. foreign trade balance, that is, exports minus imports. In fact, the aerospace industry's positive balance of trade has increased from just $3 billion in 1970 to over $13 billion in 1980. And each $1 billion of export in this industry represents about 40,000 U.S. jobs. This positive balance of payment is due to U.S. sales of commercial transport-type aircraft. The U.S. has enjoyed over 2/3 of the world's commercial transport market until about 3 years ago. But in the last 3 years, our market share has dropped 20% because of European competition in 3 years. The U.S. rotorcraft market has decreased 15%. And the commuter airplane market is now dominated by foreign competition. And our competitive position promises to become even worse in the future. It is the general practice for foreign governments to provide financial incentives for all phases of aircraft production and sales, including research and development, tooling and fabrication, as well as provisions for attractive financing. More than 20 companies in 17 nations, for example, are competing with U.S. industry for the growing worldwide market in general aviation. Brazil will sell you a general aviation airplane with almost nothing down and 7% interest on the loan. Our survival in the commercial aviation industry can only be accomplished by aggressive research and technology in the face of this stiff and expanding foreign competition. In the aircraft propulsion industry, things are particularly bad. General Electric, for example, is cutting back and laying off in its aero propulsion research and development programs because of the deteriorating profit margin in its commercial aircraft engine business. Faced with less income and higher costs, U.S. industry cannot afford to fund research and technology over the long term, that is 10 to 20 years, without government help. Industry's main concern is to survive and to make a reasonable return on its investment in the near term. The engines that you will see in tomorrow's aircraft are the result of research and technology accomplished by NASA Lewis over several decades. But NASA's aeronautical budget has declined 17% only since 1980, and further drastic reductions are probable in the next several years. The National Academy of Engineering has recently warned that the United States momentum in aeronautics is eroding. If this country fails to maintain and improve its technological capabilities in aeronautics, foreign competitors will seize even greater portions of future markets. Now, similar developments are evident in the space technology area. In the space portion of the NASA budget, there are no new starts in fiscal year 1982. The space science program has declined 20%, and space applications by 9% in constant dollars since 1980. Our communications program at Lewis will be delayed or terminated, jeopardizing a $40 billion potential market by the year 2000. A passive approach to federal policy in this critical area will be a prescription for failure. The European Space Agency has developed an expendable launch vehicle called the Ariane to compete with the Space Shuttle. It will be launched from French Guiana near Devil's Island in South America. We have already lost commercial customers like Intelsat to the Ariane. General Telephone Satellite Corporation has signed up to launch satellites on the Ariane. The Grumman Corporation of Bethpage is the Ariane marketing agent in the United States and is negotiating with several more potential customers. The United States is no longer a monopoly in the launch vehicle area. And even when the shuttle becomes operational, there will be intense foreign competition. The automotive area is even worse. Foreign imports of automobiles comprise about 25% of the U.S. domestic sales. The U.S. has become much less competitive in the international market. But the real danger is the inability to employ our own workers. The automobile industry employs directly or indirectly about 11% of the total U.S. labor force. And in spite of alarming statistics, we have chosen not to aggressively pursue promising research and technology for the long term. Our gas turbine and Stirling engine programs have been curtailed drastically with a good chance of near-term termination. The Arab nations will derive in the next 5 years about $2 trillion from petroleum exports. And the United States will pay $750 billion of this. In fact, the largest transfer of wealth that has ever occurred in civilization is now going on. $2 trillion. That's 2,000 billion dollars. That's almost equivalent to the gross national product of the United States by over 100 million workers in a year's time. Yet this country has not aggressively pursued research and technology to conserve petroleum and doesn't intend to. And as far as our military posture is concerned, the statistics are even more alarming. The Soviet Union launched 132 payloads in 1980 versus 16 by the United States, 16. The Soviets presently have over twice as many engineers and scientists as we do, and they are turning them out at 5 times our rate, 5 times. Yet this country has chosen not to support its universities of higher learning, to eliminate scholarship and research support for promising students, and in fact, we're educating foreign graduate students almost at a greater rate than United States students. Some graduate schools in this country are 2/3 foreign students, especially the good ones. A recent Brookings Institute study shows that technology is the leading contributor to productivity. The declining technology base in this country has already taken its toll. The Bureau of Labor Statistics shows that the annual productivity increase of the United States worker from 1960 to 1973 was 3.4%, which is lower than in any other major Western trading nation. Most of these countries have an increase double that of ours, and Japan's increase is 3 times ours, 10.5% versus 3.4%. Our only bright spot is agriculture. Now, none of us believe that the United States worker is inferior to the Japanese industrial worker, but the Japanese worker has the technology and capital at his disposal. If the United States wants to accelerate economic progress and increase productivity, then an incremental investment in research is one of the best, if not the best, investment that can be made. NASA could be a major contributor, but its budget is only 0.8% of our federal budget, 0.8%, and is decreasing. In fact, the present purchasing power of the present NASA budget is only about half that of the 1968 budget. And almost as bad as the low level of funding has been the cyclic nature of funding and research in the United States. Funding for research increased during World War II, declined until Sputnik in 1957, increased until 1968, followed by a precipitous decline. We now face another precipitous decline in research funding, which could have disastrous effects on the future of this country. It is time that this country came to its senses and supported the vital research and technology necessary for our economic health. Cyclic, inadequate funding is the road to disaster. I'll entertain questions later.
Thank you, Dr. McCarthy. Today we're listening to Dr. John McCarthy, Director of NASA's Lewis Research Center, speaking on local and national impact of aerospace research and technology. In just a moment, we'll turn to our question period, but first, some announcements. I'd like to remind you, those of you here and those of you in our listening audience, that the City Club's membership campaign is still underway. Those of you here know that the City Club is made up of people and that these forums cannot continue without your support. We urge you to become members, and for those of you who already are, we urge you to urge your friends to become members. Please call 621-0082 for further information. This week at the City Club, we're going to have a special midweek program. Our new leaders group will sponsor a social and program meeting on Wednesday, December 9th from 5 to 7 p.m. The featured speaker will be Solomon Harge, Executive Director of the Consumer Protection Association. I'm told his topic will be Beware of Tricks. All members and prospective members of the City Club are invited. Today, as always, we have students with us who are participating in our Living Seminars program, which we sponsor in cooperation with the Cleveland Public Schools and with the support of Sohio. With us today are students from the following schools: Bay, Beechwood, Charles F. Brush, East, Euclid, John Hay, Lakewood, Max S. Hayes, Parma, St. Augustine, West Technical, and the School of Science. Would they please stand and receive our welcome? These students will be meeting with Dr. McCarthy for their own seminar immediately following our program here today. Next week, our speaker will be Roger B. Smith, Chairman of the General Motors Corporation. His topic will be the U.S. auto industry, a blueprint for survival. Make your reservations early for this important address. Now for our questions for Dr. McCarthy. We have two microphones, one in the front with Bob Cavano, one in the rear with Bob Conrad. Please raise your hand to be recognized. First question, please.
What do you think President Reagan will do when he hears about your speech here?
I may be looking for another job. No, I think what I've said is very compatible with Reaganomics. President Reagan has emphasized that research and technology must be done in this country. We must do something to raise productivity. I think he would be very sympathetic.
Dr. McCarthy, you make it very clear that we're having difficulty competing with foreign countries in consumer and commercial fields. But don't you think it's significant that none of these countries also have in their plans $3 trillion defense budgets?
Well, my only comment on the defense budget is to look at the percentage of the federal expenditures that DOD has enjoyed. 20 years ago, for example, DOD had over 50% of the budget. Today, DOD ranges from 22 to 25% of federal expenditures. During that same period, something like 20, 25 years, the expenditures for health and human resources went from like 20% of the federal budget to like 50% of the federal budget, and is continuing to grow. So to answer your question, I think it depends on the percentage of federal expenditures.
Dr. McCarthy, you mentioned the use of ceramics. We all are aware of the tiles that fell off the space shuttle. What other application for ceramics are there beyond that?
The question about ceramics. The reason that we're looking at ceramics is because of affordability. One of the features of a gas turbine engine is to use very high temperature in the turbine blades. And in the aeronautical propulsion business, we use exotic materials like cobalt, columbium, and chromium, and so forth. You cannot do that in the automotive industry and remain competitive with the internal combustion engine. The reason we're emphasizing ceramics is because it has very good properties at high temperature. One of its problems is its low ductility and difficulty in manufacturing. So if we could make turbine blades for gas turbine engines for automobiles out of ceramics, we could cut the cost down considerably and indeed compete with the internal combustion engine.
Dr. McCarthy, I'm going to try with two questions. First one is I'm thoughtful as you're making your remarks that some friends of ours with responsibilities for manufacturing in various countries of the world point out to us that in many of these countries, a triad really makes the decisions as to where things will be researched and manufactured, having to do with the academic community, the business community, and the political community. Do you think something like that could work and it would make us more efficient in America? Second question is, how is it determined who are the recipients of the research done at NASA? What industries? How is the determination made? What criteria?
The first question is, what about a triad of academia, universities, and industries about decisions? NASA prides itself on having very powerful advisory groups made up of people from government, industry, and universities. And we constantly present our program to these advisory groups. They criticize the program, write reports, and we take whatever they say very literally. So in effect, we do have a triad that helps us prioritize our program in many areas, and we get the best people who work for nothing, incidentally. The second question was what again? Who determines who the recipient of the research is for NASA? I mentioned previously that NASA role is aeronautics and space, and we were asked to help with our national need in energy to assist the Department of Energy. Now, we are a government agency. We put out requests for proposal. We invite people that we think are qualified to bid, and anybody who thinks they are qualified can bid. We have a very rigid source evaluation process, and based on technical expertise, economic factors, and so forth, we pick a winner. Sometimes these are challenged, and there's a route for appeal, but it's a very objective process to get the best help we can at the least cost.
Yes, I also have two questions. First of all, it seems to me that the Lewis Labs and a lot of the other installations run by NASA are already, in effect, government-subsidized laboratories whose research and development is more than anything else useful to the large business corporations, industrial corporations in the aeronautics, automotive industries, than anyone else. And my second, how would you comment on that? And my second question is this. As I look at the history of the automobile industry recently, over the last 10 years, and the advance of the Japanese, it seems to me that the reason that happened was that they had better planning and long-term goals, and were not so much interested in short-term profits and the so-called high-performance engines. And that I don't think putting more money into research is going to do that much about that. And would you comment on that?
Now, the first question was whether or not Lewis Research Center is a government laboratory. We are a government laboratory. We depend 100% on the government. And in fact, if industry wants to use our facilities, the only thing we charge them is our expense, including direct and indirect costs like electricity. The way we work is to address national needs, perceived national needs. Several years ago, the perceived national needs was emissions, pollution, noise, and so forth. Today, the perceived national needs is fuel economy. We choose our research and technology projects to address current perceived national needs. They're debated at great length. They're submitted to Congress by the President. Congress debates them. And finally, we get our annual budget, hopefully before the beginning of the fiscal year. The other question was, what was the second question? Oh, about the Japanese and whether or not they have high technology. Let me just address the steel industry. Productivity in Japan per worker is twice that of the United States. The reason for that is high technology. There's no way that this country can compete with the Japanese or anybody else as far as dollars per hour in the labor market is concerned. The only way we can compete is with high technology. The way to get that high technology, which indeed is a very fragile thing, very long term, is to do the necessary research and development associated with it. The Japanese have a very aggressive research and technology program. I'll tell you, the Japanese came to our conference on ceramics in Dearborn last month, complete with tape recorders, cameras, and everything else, and picked our brains clean because they have decided to become leaders in the ceramics industry internationally. So I don't agree with you that they are not aggressively pursuing research and technology.
Okay. I read in an article last week that the United States spends $27 billion on military arms to the third world. Does NASA in any way have goes in with this $27 billion in production, transportation, or distribution of the military arms?
The only thing we do as far as foreign aid is concerned is to help the Department of State in things like standalone photovoltaic systems. As a matter of fact, we put a standalone photovoltaic system for AID, the Agency for International Development, in Upper Volta, Africa. And we were reimbursed by the State Department for this. We don't have any activity in the foreign aid business except to assist in research and technology when requested by other government agencies.
Dr. McCarthy, one of the concerns today is the storage of nuclear waste. Would it be feasible to develop spacecraft to take this nuclear waste out to the outer space, and would it have any effect on the other planets?
I'm glad you asked that question because as a professor at MIT, we did a study on how to get rid of nuclear waste, and we showed it was very feasible to take the nuclear waste, solidify it in glass, put it in a space shuttle, and send it out to the sun or to a very, very high orbit and get rid of it once and for all. The question is, what if we had an accident? We can show you that if you had an accident in the shuttle, you could contain it so that it wouldn't be any problem. I predict that eventually we can get rid of nuclear waste routinely by using the shuttle. And we showed economically that that would contribute about 5% on your electricity bill.
Plus or minus.
Eventually it'll be minus.
Dr. McCarthy, you spoke of our weakening position in the aircraft industry. Now I want to know, can we afford to forego our B-1 program and our technological advances in that study?
Well, the question is, what about the B-1 and what about our balance of payments in the aircraft business? There are really two facets. One is commercial aeronautics and the other is military aeronautics. NASA has the charter for commercial aeronautics. We think we've contributed to the positive balance of payments, and we think that unless that continues, aggressive technology will erode our market share. As far as military aeronautics are concerned, That's the primary charter of the Department of Defense, although we do assist the Department of Defense in long-range research and technology. We will take the B-1, for example, and test models of it in our wind tunnels at Ames Research Center, Langley Research Center, and Lewis, and assist the Department of Defense in developing as best a machine as they can. But our role is one of support, and we're not prime in that area.
Dr. McCarthy, we're spending billions of dollars trying to protect the rest of the Western world. Japan doesn't pay anything. Germany pays hardly anything. England doesn't pay hardly anything. Why not retrench? Let them defend themselves and use this money for research.
That's above my grade level. Well, I should point out that most people don't realize that the NASA budget is so small. We spend 0.8% of the budget. We spend in 1 year what Health and Human Resources spends in 1 week. We spend $6 billion a year. The interest on the national debt is approaching $100 billion. But we're 100% discretionary. That means we have to justify every dollar we spend. And in the whole budget as a whole, only about 25% or so is discretionary. So when the budget squeezes on, the first things that get socked are the discretionary activities.
You mentioned earlier about specific colleges that had about 2/3 students from other countries other than the United States.
Graduate students.
Graduate students. Are you suggesting that graduate students over the world are overqualified or more qualified than American students? Or are you indeed suggesting that our major problem is is in education, that we should start competing with other markets by improving our educational quality?
Let me comment on the university system. People take certain courses because of their parents and the trend of the times. When I was a professor at MIT 5 years ago, we had the lowest graduating class in aerospace in the history of the school, even lower than during the Depression. We graduated 13 students 1 year. And incidentally, each one of them had about a dozen offers for a job. There are two problems in this country. One is that the accumulator, the number of undergraduate students, is not there for graduate school. The other is that the incentive now is so high for a student to go out and make a lot of money. The starting salary for BS in aeronautical engineering now is like $25,000 a year. Why should a student stay around and be a peon if he can go out and make $25,000 a year? And the research and technology is drying up. We would subsidize our graduate students with research grants we got from the government. Now, those are all drying up. So there is no visible means of support to have research assistants to work on research projects where they would not only get their tuition but get a reasonable salary so they could survive. The foreign graduate students that come here are subsidized by the government. Full salary, full tuition. They don't have to worry about anything except getting good grades. Of course, we don't treat our people that way.
Dr. McCarthy, it's been said that if NASA is going to have a future, Lewis said that it's going to have to adapt itself more and more to the Department of Defense and its technology for the military machine. Do you think the future of NASA is more of a military research center?
The question is, what about NASA Lewis's role in the Department of Defense? We have always supported the military. I mentioned in Aeronautics that we had 3 main goals, one of which was to provide the technology for U.S. superiority in military aircraft. The only thing that I'm doing now that I haven't done before is to emphasize the fact that we do support the Department of Defense. It was more or less accepted as a routine thing to do. None of it's classified, by the way. It's all basic research and technology. is to show what our contribution has been to the Department of Defense. People don't realize how much we do, and as a matter of fact, the Army, the Navy, and the Air Force have written letters to Stockman and Company supporting the work that Lewis has done and have advocated not only keeping us but increasing us in the future. So our emphasis is to just give it more emphasis in the public relations arena rather than changing the activities at the center.
Dr. McCarthy, we recently read in the newspaper about the direct conversion of solar energy into electric use. This was within the last week, I believe. Would you comment on that story if you saw it?
Let me give you a little background before I answer that question. One of the things we have responsibility for at NASA is the solar cell research for space. JPL, Jet Propulsion Laboratory, has responsibility for solar cells in terrestrial applications. And we're looking for always bigger and better means to improve efficiency. Now, in our standalone photovoltaic systems, we built a system in Chicxulub, Arizona, for the Papago Indians, by the way. We put up the solar cells, we put up the energy distribution system, the energy storage system, and we even wrote the manuals in 5th grade English for the Indians so they could operate it themselves. We can, with present-day technology, we cannot generate electricity for less than about $1.80 to $2 per kilowatt hour. That compares to 4 cents that I mentioned for wind turbine. So, except for unusual applications, standalone places in the forest where you can't get electric lines in and so forth, solar photovoltaic systems are not competitive economically. And we don't expect them to be until the late 1990s, and probably never if we don't do any research and technology.
Dr. McCarthy, what other government agencies other than NASA are engaged in basic research having to do with propulsion, energy, or space, and to what extent, if any, in your judgment, do they duplicate what NASA does?
The question is, what other government agencies are involved in propulsion? The only other government agency involved in propulsion is the Department of Defense at Wright Field. They're more of a conduit for money than they are as a hands-on basic research establishment. There are no other government agencies involved in propulsion other than Lewis. And their emphasis is on military engines rather than commercial engines, which have completely different requirements than the commercial engines. So commercially, we're the only ones. Militarily, the DoD has some activity, but more or less as a contracting agency rather than a hands-on agency.
Dr. McCarthy, you mentioned some of the economic benefits of the space satellite communication system, but there are many people that feel that travel in space is for the delectation of scientists and sensation seekers, and I wonder if you could give us any down-to-earth consequences of those programs. For example, what does it mean to know what's happening on Venus?
Well, there are two aspects of space. One is the space science area, and one is the applications area. In the space science area, we have a much better understanding of what goes on extraterrestrially, the origin of the planets and so forth. In the applications area, we're exploiting rather than exploring technology. Every time you pick up a telephone, you use a communication satellite to transfer your call to Europe or to the Pacific. Every time you look at television for a weather forecast, you look at a satellite picture of what's going on. We are now in the age of exploitation. We have ideas that will astound you. We have ideas for communicating mountains of data, for transferring information systems, for exploiting the oceans to know where the fish is, for finding ore and oil, Our expertise at NASA Lewis is communications. We think eventually the Mickey Mouse watch will be a reality. We think you can get antennas in briefcases for search and rescue or for just mere communication. That involves very high frequency, very complex satellites, but very low-cost ground terminals. So the emphasis is to put all the complex, high-cost stuff in the satellite and let the user have a very small, low-cost device. Navigation is another one. We can get you within a couple of feet in 3 dimensions of where you are using our NavStar, global positioning satellite. If you own a boat, that would be great.
Dr. McCarthy, there's been rumors spreading that there might be a possibility of a third world war approaching. And because of this, it might be a nuclear war. If war does break out, what's the role that NASA would play?
If war breaks out, every technical activity in this country will be geared to winning it. And I'm sure NASA will be involved. We made tremendous contributions during World War I and World War II, and there's no reason why that shouldn't continue in the future if the need exists.
Doctor, you mentioned that you're doing quite a bit of research with automobile engines using petroleum as a means of propulsion, as a fuel. What other alternate fuels are you investigating?
Our emphasis is on broad-spec fuels. We expect the petroleum-grade oil for either gasoline or kerosene to be very, very inferior to what it is today. And our initial emphasis is on burning crude oil that comes from the bottom of the barrel. Eventually, we'll expand to other activities like alcohol, methanol, and so forth, both for aircraft engines and for automotive propulsion, assuming that the research and technology funds are available.
Thank you, Dr. John F. McCarthy, Jr., Director of the NASA's Lewis Research Center. The City Club Forum is adjourned.